Do you remember the absolute magic of getting the internet on a phone for the very first time? You know, that tiny pixelated screen suddenly connecting you to a whole world of information? Well, the technology that actually made that possible was a really clever piece of engineering called the Wireless Application Protocol, or WAP for short. So today, let's dive into this and see exactly how it worked. All right, so here's our game plan. First, we're going to define what WAP actually was. Then we'll zoom out and look at the big picture, the communication model that connected your phone to the web. After that, we're diving deep into the core tech, the protocol stack, and we'll break down each of its 5 layers to see how the magic really happened. So first things first, what exactly was this protocol? Well, you can think of it as the essential bridge, the thing that was specifically built to connect those tiny, underpowered mobile devices of the late 90s to the huge, powerful internet. At its heart, WAP was a special set of rules made just for the micro browsers on those early cell phones. I mean, think about it. These things had teeny tiny processors, almost no memory, and painfully slow connections. WAP's entire job was to make the internet somehow work within all those limitations. And this wasn't some niche little project either. The WAP Forum, which started in 1998, was a team-up of the absolute giants of the time. We're talking Ericsson, Motorola, and Nokia. One of their key ideas was using a stripped-down language called WML instead of the heavy HTML we use today. That was totally crucial for performance. And as we're about to see, its layered structure took a lot of inspiration from the TCP/IP stack that powers our internet now, which was a really forward-thinking move. Okay, so we know what WAP is. Now let's zoom out and look at the whole system. How did all these different parts actually connect to get information from a web server all the way to your phone's screen? And that's a really good question, right? I mean, those early phones just didn't have the power to speak the same language as a massive web server. They needed a translator, some kind of middleman to do all the heavy lifting for them. And this diagram shows the solution perfectly. It all came down to 3 main parts. You had the client, that's your phone. You had the web server, which had all the content you wanted. And then smack in the middle was the most important piece of the puzzle, the WAP gateway. So this gateway, it was the secret sauce. Your phone would send out this tiny, compressed, encoded request. The gateway would catch it, decode it, and turn it into a standard web request, just like one from a desktop browser. Then it would go get the content from the web server. But here's the clever part. It would then do the whole process in reverse, compressing and encoding everything before sending it back to your phone in a format it could understand. Okay, now that we've got the big picture, let's zoom in even closer. We're going from the overall system to the specific layers of technology inside WAP that made this whole conversation happen. This is where the engineering gets really elegant. WAP's architecture is built on something called a 5-layer stack. A good way to think about it is like a stack of building blocks. Each layer has a very specific job to do, and it provides a service for the layer that's sitting right on top of it. And here they are, all 5 layers. You've got the application layer at the very top, going all the way down to the transport layer at the bottom. We're going to break down what each one does, starting from the foundation and working our way up. All right, it's time for the deep dive. Let's really unpack the specific job of each of these 5 layers that made the early mobile web even possible. So at the very bottom of the whole stack, we have the foundation, the transport layer. This layer is the Wireless Datagram Protocol, or WDP. I like to think of it as a universal adapter. See, back then, there were tons of different wireless networks. This layer's job was to grab data from any of them and present it in one consistent format that the rest of the stack could actually work with. It basically created a common ground for everything above it. Now, sitting right on top of that foundation is the layer that's responsible for keeping everything safe and secure, the security layer. This is the Wireless Transport Layer Security, WTLS, and it had 3 really important jobs. First, data integrity, making sure the info wasn't messed with on its way to you. Second, privacy, using encryption so no one could listen in. And third, authentication, making sure you were talking to your bank's WAP site and not some fake one. Yep, even way back then, security was a big deal. Okay, next up is layer 3. This is the manager, the layer that keeps track of all the back and forth between your phone and the server. This layer, the Wireless Transaction Protocol, or WTP, is all about reliability. It's the part of the stack that makes sure that when your phone asks for something, it actually gets a reply back. it keeps the whole conversation neat and tidy, organizing it into these clean request and reply transactions, so data doesn't just get lost in the ether. Moving on up to layer 4, we get to the session layer. This one is all about making the connection work efficiently, especially over those old, spotty mobile networks. The function of this layer, the wireless session protocol, was so clever. It could actually suspend and resume a connection super quickly. So let's say you drove through a tunnel and lost your signal. WSP could just pause the session, and then when you came out the other side, it would pick up right where you left off without having to start a brand new connection. This was absolutely vital for making mobile browsing usable at all. And here we are, at the very top of the stack, the application layer. This is the one that the microbrowser and the actual web content interact with. The wireless application environment, or WAE, pretty much defines the world where these little mobile apps lived. It provides the whole framework for the WML language and tells the phone how it should interpret and display all the content. This is where everything finally comes together for the user. So let's just recap real quick. We have this really elegant 5-layer system, right? The transport layer provides the common base, the security layer locks it all down, the transaction layer makes sure requests are reliable, the session layer manages the spotty connection, and finally, the application layer brings it all to life on your screen. WAP itself might seem like ancient history now, but it was such a critical first step. And it leaves us with a really fascinating question to think about. How did the core ideas that were pioneered here, things like gateways that translate content and layered protocols designed specifically for wireless, how did those ideas pave the way for the incredibly complex and powerful mobile internet that we all carry around in our pockets today?